So welcome friends, welcome to Surya classes once again. So today our topic is how we are going to, we are going to check out this fact. This is actually based on a fact checking, you can say, fact checking video. So what is the fact? The fact is the capacitor is helping you to make your electricity bill reduced. So is it so? This is a question and we will have the answer at the end of the video. So be connected to us throughout the video if you want to get the answer of this fact. Okay, so let's check it out. Now the connections. Well, the connections are very simple. This is your electricity pole or the transformer from where you are getting the electricity supply. That is into form of 230 volt 50 hertz single phase, and this is your home. Fine. So in this you are getting the supply of 230 volt 50 hertz. So up to here I think everything is clear to you. Now whenever you are getting the 230 volt 50 hertz, so at that time, if you connect the capacitor in parallel to the line, so this will make your bill reduced. This is the fact we are checking. So this is said that bill is reduced if you are connecting the capacitor in parallel. Now what happens when you are connecting the capacitor in parallel? That is what we are going to discuss into this video. Before that, I would like to describe or define three terms for you. So you might be thinking that what is the link of this active, reactive and apparent power to this capacitor theory, to this capacitor, light bill theory. So I will tell you everything. Just look at this theory and then after we will connect it with our, main fact checking. So see what is active, what is reactive and what is apparent power. This is actually slightly tilted but it can be straight as well, but you just think of it. Okay, think of it, assume it as straight. This is your active power P, this is your apparent power, okay, this is your reactive power Q, this is your apparent power S, and this is the angle theta, you can say. Okay, so now see what happens. If you see the formula of the active power, that is VI cos theta. If you see the formula of reactive power, that is VI sin of theta. If you see the apparent power, okay, if you see the apparent power S, this equation is square root of active power square plus reactive power square. So when you put the values of active power as well as reactive power here, you will get the value of S, that is your apparent power. So now what is the purpose of explaining you all this? The purpose is very simple. The power that is being delivered to you is not only in form of P, but this is into the form of S, because the apparatus that are connected at your home are not only consuming the active power, but they are also consuming the reactive power, that is into form of Q. Okay, that they are also consuming the reactive power. So now what is the reactive power and how it is being consumed? So this is the question. So before going into that detail, I would like to tell you the formula for the power consumption at your home. Power consumption at your home, that is VI cos of theta, where cos theta is your power factor. That is what? Power factor. Cos theta is your power factor. V is the input voltage, that is 230 volt. I, that is the current that is actually dependent on the power consumption or the current consumption of your home appliances. and P is the multiplication of all these, or it is the product of V into I into cos theta. So now you are being charged of what? Now this is actually getting a little confused for you as well, for what you are getting or you are being charged. You are being charged for the energy consumption units. You are being charged for the energy consumption units. Consumption, okay, just look at this spelling, no issue. This is energy consumption units for which you are being charged, or they are into form of units. Now, actually what are the units? In electrical term, the units are nothing but kilowatt hour. That is kilowatt hour. Now let me tell you what is the unit of P. That is watt. Okay. P means watt, or you can say kilowatt. Okay. What is the unit of Q and S? S unit is always in kVA. kVA is the unit. This is for this kilowatt hour. That means you are being charged for what? You are being charged for this kilowatt, or you can say this watt of consumption. So now you have to take care of how much active power you are consuming from the supply. Now let's take an example. So theta is 90. Let's suppose theta is 90, not it's a 0. Let's suppose if theta is 0, then cos theta would be unity and P would be equal to V into I only. And let's suppose if theta is 0 degree here, then Q would be 0. So just don't go into that much detail, but what we can do is we can have this kilowatt hour. So energy consumption for which you are being billed or charged means for which you have to pay the money, that is nothing but energy consumption, and you are being billed or charged for the energy consumption, and that is measured into the kilowatt hours. And if it is measured into the kilowatt hour, then you are being charged for nothing but active power only. What you are being charged? Active power only. So here, whether the reactive power is being consumed by you is more or less, that has nothing to do with you, but how it will affect you and your home appliances, that we will look at. So now let's have the explanation of this. Now let's suppose your home power factor is of 0.5. Okay. The power factor is into the range of 0 to 1. So as much as the power factor is, that is good for your electrical supply. So power factor is to be maintained above 0.6 or 0.8 or 0.9. So that is as per the standard, but let's suppose your current power factor of your home, that is 0.5 only. Now let's suppose you are consuming 230 volt and your home appliance is working on 1 ampere. That is the value of current and this is the value of voltage, and now power factor is 0.5. So the power that you are consuming and you will be charged. Okay. So this will be 1 and 5 watt only. So you will be charged for this 1 and 5 watts, whether you are consuming. Okay, now let's suppose you are connecting the capacitor into your supply. Now what you are doing? You are connecting the capacitor now. This is actually without capacitor. Without capacitor. This is actually without capacitor and this is with capacitor now. This is with capacitor. So the power consumption of your home is now, let's suppose 115 watt only. Now if you are connecting the capacitor, okay, then P will stay, P is equal to V into I into cos theta, let's suppose. Okay, so P that you have calculated, the power consumption of your home is 115 volt. So if you just put the value here 115, voltage would be same 230 volt, I would be different here. Now let's suppose with capacitor the power factor value has been increased to 0.9. Actually the capacitor is doing nothing but the work of capacitor is to increase the power factor. The work of capacitor is to do nothing but to increase the power factor in system. Now capacitor has increased the power factor to 0.9. Okay, now let's suppose if the capacitor value is 0.9 now, then how much current you will be dealing with? It is now 115 upon 230 into 0.9 upon 0.9. Then the new current value that is coming 0.555. So 0.556 I can put. So it is around 0.556 only. So now the value of current you have derated, or you have decreased the value of current. The new value of current has been decreased to 0.556. Now the current consumption of your house that you have reduced, but the power would stay same here on as well. If you calculate the 0.556, the new power value with new, see, the new power value, the new power with 0.9 value of power factor, 0.9 of power factor. So here again P is equal to VI cos into theta. So V, that is nothing but 230, 0.556, and cos theta is 0.9. So now let's calculate 230 into 0.556 into 0.9. So this is also coming 115 volts only. So the P would stay same. So the for which you are being billed, or the money that you are being charged would be same here. You will be charged same money. Okay, so here by installing the capacitor at your home, you are being charged the same money. So the fact has been checked now. So the fact has been checked and found false, that by installing the capacitor you are not saving your money. You have to pay the same amount of money whether you are installing the capacitor or if you are not installing the capacitor. Now what are the advantages? It is nothing, it is not like that if you are installing the capacitor then you will not be saving anything. Now see how you will be saving your electricity, or how you will be saving, how you will be getting advantage of it. So now let's suppose there is a term resistance. So if you measure your house resistance, if let's suppose I am assuming that your house resistance is of 100 ohms. It is not actually possible if it is 100 ohms. Okay, then if you are applying the 1 ampere of supply, then the voltage drop, would be multiplied with this 100 ohm. Okay, I mean voltage drop would be multiplied with this current and you will get the voltage drop. So it will be around 100 or multiplication of 100. It will be proportional to V and I. R into I. That is actually IR. Okay, so if your current is more, then the voltage drop would be more. If the current is more, then the voltage drop across your house, that would be more. If your current is less, current consumption is less, voltage drop would be less. But that is very minor and that will not affect your light bill. Now, this is the actually first advantage. The second advantage is your house appliances life would be more. Why more? Because your house appliances would be consuming less current, and if they are consuming less current, then heat would be less, loss would be less. If the heat is less, loss is less. If your appliances are not getting heated up, they are not at high temperatures, then they can run for more life or longer life. This is the second advantage. Now the third advantage is not relevant to you, but it is relevant to your electricity board. Your electricity board. Now how it is relevant to your electricity board, that I am explaining you here. You know, whenever the power lines are coming, they are first coming into the device that is called transformer, and this transformer is rated into kVA. So the transformer is not only supplying the active power, but it is also supplying the reactive power to your house loads. So if the reactive power consumption would be less, if you are installing the capacitor, by installing the capacitor, okay, then it has to only supply the active power. Now in case of, if you are not installing the capacitors, then the 115 volt, that was constant. Okay, if you are not supplying the if you are not installing the capacitor, then the active power was constant and there was some value of reactive power. There was some value of the reactive power. Now see, one equation we can also check it with one more equation. Q is equal to VI sin theta. Okay, that is the equation for reactive power. 230 volt current, we are taking 1 ampere, sin theta. Theta value if you want to find out, then cos theta we had 0.5 and this is equal to cos theta. Okay, cos theta is equal to 0.5. So now if you want to take the value of theta out, then cos inverse of 0.5. So cos inverse of 0.5, if you find out the value of theta now, then if you are putting the value of theta here, by using this you will have the value of Q, and for the value of theta is equal to the power factor 2.9, the sin theta value will be decreased for 0.9. okay, and for 0.5 the sin theta value would be more. For 0.9 the sin theta would be, you calculate it separately, it is very simple. For 0.9 sin theta value will be less, and for 0.5 sin theta value would be more. So for 0.5 of power factor, your Q value would be more for 0.5 and it will be less for 0.9 value of power factor. Okay, so this is how you can calculate the value of Q here. And if you are calculating the value of Q, then you will come to know, for without capacitor the active power was 115 and the reactive power was more, and for with capacitor the active power was same, 115 volts only, but the reactive power was less. So overall loading to your transformer installed outside will be installed with less kVA. the kVA installation will be reduced, and this will also affect at the power generation, power generating station where the alternators are installed. The alternators would also require the lesser capacity because kVA capacity has been reduced. So this is the main advantage of installing the power factor, but this is not actually affecting your light bill, but it will enhance the life of your appliances. It will also reduce the voltage drop across the circuit. It will enhance the life of your appliances, and it will also reduce the electricity installing devices of particular electrical company. Okay, like transformer and alternator size would be reduced due to the power factor installation at your home. So that's all, guys, with this video. I hope you understood this, the concept, the fact we have checked, that how the capacitor can give you the advantages, but not in terms of money, but in terms of your electrical appliances or home appliances life, as well as it is giving advantage to the electricity company, and it is reducing somewhat of voltage drop across your house circuits. Thank you so much for watching this video. Let's meet you again in my next video. Thank you so much.